Today we're going to talk about batch settling for multiple particle systems. So up until now we've been discussing the idea of a single particle falling at a terminal velocity, assuming more or less an infinite fluid. And in that case we simply had the particle, it was falling, and the fluid was moving around it. Now we have to consider the fact that we are going to usually have much more than a single particle in the system. The minute you start adding additional particles to the system, you can quickly see that they're going to begin interfering with the flow around them. So now those particles are falling through the system, and the flow of the liquid is going to have to take various routes in order to get around those particles. And so now things are no longer going to travel at their terminal velocity because the relative velocity between the fluid and the particles is going to be different. First, we need to introduce a little new terminology. We're going to use the Greek letter epsilon, the little e, to be defined as what's called the voidage, or rather the volume of the liquid, the volume fraction of the liquid. That means that we can then also define a new term, c, which is going to be 1 minus epsilon, and that is going to be the concentration of the particles. Or rather, the volume fraction that is the particles. So again, we have epsilon, which is the voidage or volume fraction that is the liquid, the percentage that is a liquid, and c, the concentration of particles, or the volume fraction that is the particles. So we have a graduated cylinder filled with particles in a liquid that have the concentration B, that is the batch concentration. And over time, those particles are going to begin to settle, such that the bulk of the concentration of the batch remains at the same concentration B, while the particles that have left the top leave a clear liquid, which we're going to designate with the symbol A. And then finally, the particles that have settled out form a very tight concentration in the bottom we call S for the sediment. So we have our concentrations, B, A, B, and S. And we can put those on a plot where we actually measure over time the locations of these. And so the interface between A and B is going to start at some initial height here and then continue to decrease, while simultaneously the interface between B and S is going to rise over time until they get, at some time, they reach the same height, and you have a unchanging concentration of clear liquid A over sediment S. So we have here the example of what is called a type 1 batch settling test, where we have the height of the clear liquid and the interface with the batch main concentration B going down over time, while simultaneously the sediment is rising until they, at some specific time, reach the same concentration, and then you have the clear liquid A and the sediment, and nothing is changing with time. Another type of batch settling test is called type 2. The only difference between type 1 and type 2 is that you're adding a fourth layer. Besides the clear liquid, the batch concentration B, and the sediment S, you've now added a new concentration that we call E. And E is a variable concentration zone, which effectively just simply changes this line here to be a line which would be BE minimum. And there's also another line that might go this way that would be BE maximum. And the resulting concentration profile simply turns into a little bit of a curve instead of a sharp interface. So now we can use a height time plot, which we could just get by simply recording the height of an interface over time, to interpret how fast these particles are settling. So if you look at any particular point on the plot, it has a time associated with it, t, assuming we started at t0. It's got a height associated with it, h, and the slope of that line at that point will intersect the height back at t0 at a height h1. So if we wanted to know the velocity of the interface, it's simply going to be the change in height over the change in time, which in this case is going to be going from height 1 to height h over some time t.